Hello and welcome to another building science webinar. This is Joey Starr from Southface. Today we're going to be talking about combustion safety. We're going to go through a little bit of housekeeping first as people start to kind of trickle in. If this is your first one, welcome. This is about number 10 in our series of building science webinars. We definitely see some familiar faces. I'm seeing some chat now from some of our friends in North Carolina and other places, so thank you very much. So if this is your first time using GoToWebinar or like us, you use about 15 of these different services a day, then here's just a quick update or on how to use this. Click on that little orange arrow. That's going to expand your control panel. You can do a lot of fun stuff there. You can look at your audio settings, right, Mike? You can
Yes.
also look at the questions and answers, and that's the best way to get in touch with us during this webinar. So if you have any questions, concerns, we're going to try to get a little bit interactive toward the end. We'll see how that goes. So hopefully the Q&A is working out for you. Keep in mind, as always, we do have a couple of handouts. You'll find a copy of this presentation here. You'll also find what we call the small commercial building assessment combustion safety something. It's a really nice guide on combustion safety. This webinar is being recorded, so we'll send you a copy of the recording at a later date. Let me just verify that it is recording while I'm thinking about it here. And it is. Thank you. As always, keep in mind this webinar is for a general audience. We've got HERS raters, BPI folks, general homeowners, everybody else. So we hope that everyone gets something out of this, and keep the questions and comments coming. So without further ado, I think, like I said, my name is Joey Starr. I'm a technical project manager here at Southface. I do a lot of the weatherization training as well as some programs and projects related to healthy homes and whatever else I can get my hands on. And hopefully by now you know Mike.
Yeah. Hi, everybody. I'm very excited to be here. Thank you, Joey. I really enjoyed doing these with you, and it's hard because it's been a whole month since we did one. So I'm missing you. And so air hugs to you, Joey, and air hugs to everybody on here. I come at the world from the mechanical engineering side of things, but I do have a lot of construction experience, and certainly try to teach a lot of building science and house as a system topics, and I can't think of a better one than this one. So this one is one that to me just has some of the best stories involved with it, and just absolutely, I find it just fascinating. So I hope everybody listening does too. I thought I'd show, kind of get us a little more formal. So I found a little more formal picture of me wearing a tie and a jacket, and then I was looking for one for you, and I don't know. Looks like you might have something on your chin. I'm not sure
No
about
way.
that. No,
Not
yeah.
me.
So yeah. Anyway, well, about Southface, we're a nonprofit based here in Atlanta, and thrilled to be connecting with people all over the country. Lots of ways you can get involved with our organization and help support us. And we do really appreciate the feedback we get, both during the webinars, but also, we have a lot of great comments and feedback from folks sending us emails. And our emails, I believe, are on the previous slide, but also on the very end. So
Yeah. And like you mentioned last time, we've updated our website, so do check that out. And the first thing you're going to see there, you should get a pop-up that asks you to vote for us. This is a really easy
oh
way to
yeah.
support us. We're in a contest basically, and we need votes. So if you've been wanting to support us and you want to make it the easiest way possible, there's literally a contest where you click one time to support Southface. So if you've been enjoying the webinars, I think that's the least you can do here is help us out there. So
Yeah, but that'll wear out my finger, that click. All right, but anyway, no, good comment, good reminder for that. Yeah. So also, we have been pushing the resources that we have available, and it turns out I requested, we developed some small commercial combustion safety guidelines. You could replace the word small commercial with home. And I think this is some great resources that we were able to do a few years ago. So they're still pretty current. And I definitely want people to take advantage of these. And you can get to these in the Georgia Energy Code section, or you can get to them from the, I want to say, library resources library section as well. So please take advantage of some really good stuff about combustion safety. And again, we usually put a slide like this, just kind of tying building science in. This is just, like I said, probably one of the best examples of, in essence, house as a system, putting it all together. Again, ultimately, combustion safety is really very much about the people living in the house and the impact on them. So Joey, I was going to share a story just very quickly. This one was relayed to me by a friend in North Carolina, and it was talking about a multi-story house with a basement. And the family that lived in it had some kids, and I guess the little girl grew up and got bigger, and probably at some point they decided to finish out a room for her in the basement. So the basement was kind of partially unfinished, and they finished out a space for her so she could have her own bedroom. And for many years, for a number of years, she was always sick, and she was always sick in the summertime, and she always had the flu and in the summertime, and they never could really figure it out why she was always sick. You might have an inkling of what the problem was. The problem was that she was being poisoned by carbon monoxide gas, and the appliance that was backdrafting was the gas water heater that was located in another part of the basement. And then you kind of go, okay, well, why was this only occurring during the summer? And the answer is, oops, I'm sorry, I went back. I was trying to kind of show them the diagram up here. This gas water heater had a chase that had the flue pipe running straight up through interior wall, through the roof and out through the attic and out the roof. And the chase was open at the top and open at the bottom. And so basically, you could be in the attic and drop a nickel and it would fall all the way down into the basement. Well, okay, that shows the connectivity of the attic to the basement. But the thing that caused the depressurization, or the negative pressure, which overwhelmed the water heater's ability to draft, was a fan that was located up in the attic. In fact, it was one of those things that we really hate, those stupid power attic vent fans. So they had a power attic vent fan or two up in the attic. It caused a ginormous negative pressure in the attic. That negative pressure was connected to the basement, and a pathway was for air to kind of work backwards down the flue pipe of the water heater, backdraft the water heater, and that was the source of the problem. So I can't think of a better house as a system situation. And also, usually at some point when we talk about combustion safety, I give my Spider-Man talk. Do you remember what I always say about Spider-Man, Joey?
Refresh my memory.
Well, with great power, with great power comes great responsibility. And so I'm tasking the people on this webinar to take on and shoulder that responsibility, because a lot of people in the design and construction world and don't really understand the house as a system and the ways that something that is 3 stories away can backdraft a water heater and make someone sick and literally poison a kid. So I think this is a big message. Okay, having said that, let's try to drive onwards. That was a teaser. If you're not one of these people, can you let us know in the chat? Send us who are you? Who's not represented on this list? But this is our typical constituency. Anything you want to add to that?
Nothing. Doesn't look like. I think by this point, after 10 of these, we've got it nailed down. I haven't gotten any angry responses about, hey, you forgot me.
You forgot real estate people. So yeah, so maybe we'll get some of those too. Here's what we're going to cover. Just a real quick overview of what happens during combustion. And I'm going to tell you that a long time ago, I was reading the fuel gas code, which is an exciting document. And I realized you could simplify the whole world if you just followed 2 rules. And so we'll talk about that. And ultimately, the biggest thing is not usually the appliance. It's the context.
Mike, I think you dropped off there for just a second. All right, everyone, just bear with us for just a second while we deal with the technical difficulties. I think what he was about to say is that combustion safety is about context. So not necessarily the appliance itself, but the things around it, the venting, the pressure differences in the area, and how things that we do inside the house can kind of affect the combustion safety of the appliance, particularly those of us in the weatherization and energy efficiency world. The air sealing that we're doing, the bath fan that we're installing, those all have major impacts on. Um,
Hey,
uh, hey, I can hear you
I'm
now, and
back.
I can also, yes, hello. Mike, it seems as if you've dropped off again. I don't know if you're hearing me or not. But I will press on here. Another learning objective that we're going to do is just talk
Florida.
about relative safety in different scenarios that we're going
Well, that's
to
good.
show you. Okay, you just fast forwarded about 5 seconds. So I think if you can give me a sound check, still not hearing you. Okay. And then we're going to utilize guides and tools to help us assess combustion safety. And we do kind of like to put kind of jokey titles to some of these webinars, and this one was no tools required. So we're going to talk about some guides, but we're not going to put our hands on any tools as much as we'd love to get some hands-on training. And we feel like that when we're doing a BPI test, we're very concerned about testing and that kind of makes us, we can't see the forest for the trees sometimes. And I think the same thing with our ResNet HERS raters as well when you're thinking about um, the combustion safety simulator that we use. So
I'm
Mike,
back. Can you hear
hello.
me? Yeah.
I can hear you now.
And it's interesting. Yeah, it's interesting. I liked what you said, and I would say the best tool in here is your brain, and that's what we're going to try to really focus on. So, a quick review. Of course, this is very much about pressure. Pressure, of course, moves from high pressure to low pressure. Air moves, and of course that balance. If a cubic foot of air is leaving through a flue pipe and that appliance is connected to your house, a cubic foot of air has to replace it. So that's very important to remember. And of course, the driving forces that affect pressures like the wind and the stack effect, which is how many combustion appliances vent, and of course, fans as well. So can you still hear me, Joey?
Yeah, we're good.
Good. Joey, you put this slide in there, and I was trying to think, what should I put for the bullet for this? And then I decided, we've all seen this triangle, so that was my comment. Anything you want to add to that?
No, I think you got it.
I thought it was pretty funny, but yeah, you have to have fuel, you have to have oxygen and heat or an ignition source for a combustion to occur. A little bit of chemistry. We're typically talking about burning hydrocarbon fuels, which the simplest one is probably methane, which is what you're showing here. There's a carbon atom with 4 hydrogens around it, and we have to mix it with air, and there's a chemical reaction with a spark and ignition source, and it's an exothermic reaction, so heat is released as a product of combustion, and then the what is it? Not the atoms, the molecules recombine, whatever. Boy, I'm good at chemistry, and we end up with carbon dioxide and water vapor. So that's what comes out of the process, and that's the theoretical perfect combustion. There's also, it's really not pure oxygen. There's also stuff in the air, other things in the air besides oxygen. In fact, I think air is mostly nitrogen. So when you have perfect combustion, you kind of think about it as the hydrocarbon fuel mixes with oxygen, and the other stuff in the air doesn't really do anything, and then it gives off heat, and you get CO2, and you get water vapor, and you get the stuff coming through as well. And again, that could be a different hydrocarbon fuel, like it could be propane, I think is C3H8, you know, or kerosene, or all kinds of hydrocarbon fuels. But ultimately, there's some sort of chemical reaction and some recombining. And in perfect combustion, you get CO2 and water vapor. In imperfect combustion, you still get those same two things as a result. You get carbon dioxide and you get water vapor, but you also get, because it didn't completely burn or completely mix, you get carbon monoxide, and then you get the other stuff mixing in too. I call it stuff oxides. So that's things like NOx and SOx, which somehow reminds me of Dr. Seuss. And none of those are good for you. None of those things are things you want to breathe. So I definitely want to lay that out there. Joey, you want to kind of get into the medical definition of what happens when carbon monoxide affects humans?
Oh boy, gee, thanks. So basically, carbon monoxide bonds more readily to our bloodstream, and it creates carboxyhydro something or other.
Yeah, I was gonna
And
say.
the long and short of it is it's not good. And when it creates that in your blood, it prevents oxygen from bonding in your blood, and that's not good. And that's where you start to see these headaches, flu-like symptoms, etc., because your
And
body is reacting to that lack of oxygen.
right, very well done. And I was going to say, this kind of looks like a Sunday morning for you after a really hard Saturday night, isn't that? Is that safe to say? I don't know. I don't know if I can say that. But yeah, no, the symptoms are. It's interesting because it has very similar things to the flu, but you don't have a fever. So some interesting, sort of misdiagnosis sometimes occur. People think they have the flu, but it's actually CO poisoning. And every year, some number of people die from this. I see different statistics, and certainly a large amount of people are poisoned by it. So that's very serious. It's kind of like another issue where we've been talking about, let's say in the last couple of months, that it's the exposure and the dosage, and those are kind of the factors. So you can die at 1,000 parts per minute in an hour. You can die at 500 parts per minute in 2 hours, and so on, that kind of thing. And then there's a theoretical, upper limit that in an 8-hour time period, OSHA used to, I just remember the 35 parts per million, but that's not good for you. And we have data on sort of high level, how long it takes to kill you, but we don't have as much data on low level CO exposure over a long, long time. We know it's bad for you if you have respiratory problems, if you're elderly, if you're pregnant, your fetal development is bad. So there's lots of concerns about it. But we don't have as much sort of, hard data on it. And Joey, you want to kind of explain, this is, I think, really important, the difference between a CO alarm and a CO monitor.
Yeah, so our CDC says that CO detector is going to be able to stop the CO, but that's not really true, right? So you have to have the proper kind of CO monitor. And Mike, you say that this is a political decision. I won't throw anybody under the bus, but it seems like if what we were just looking at said that 35 parts per million or even 8 parts per million is not good for you. And your typical CO monitor will think that that's perfectly fine over the course of a period of time. So what we recommend at Southface is a device like this that's actually going to give you a digital readout. It tells you exactly how much carbon monoxide is being produced or is in the air. And remember, in a perfect world, there should be no carbon monoxide in your home. And any amount kind of tells you that something might be wrong with the venting, or the appliance itself might be producing high levels. So I would really recommend something from the Defender company, does pretty well. I also noticed that Kitty is doing the one with the readout as well. And would you look at that, it's only $10 more. So if you're in the hardware store, go ahead and spring for the extra $10. It's definitely worth it.
Yeah, but I'm going to say don't buy that one because it's still a CO alarm. I want to remind people the difference between an alarm is intentionally weak in its sensitivity. And that was because in the early days, they were getting nuisance alarms. And so I'm going to say it's going to cost you more. Certainly at least have the alarm for sure. And I agree with you. If it's 45 or 55 bucks, get the better one. But I'd rather you spend, I don't know what they're running, $100 bucks, or probably more than that, for a CO actual monitor, which is really going to measure much lower CO parts per millions. Like you said, I want to, the canary is going to chirp at you a lot sooner with one of the monitors than with a CO alarm. But yeah, good point. And then also just want to mention, it's not just carbon monoxide. There are other aspects of combustion that are not good for us. Nitrous oxides is a component of ground level smog. We know that's bad. Sulfur oxides are components of acid rain. That's not good for you. And of course, there's particulates, and even in itself moisture, and then there's some other things on the bottom sentence I can't even pronounce. So, ultimately, we really don't want to breathe the products of combustion. And then in terms of, an existing home, you really have to be paying attention, because you go into an existing home and you do the typical weatherization air sealing. It's possible that you have a problem in that home that you make worse, or it's possible that the home was right on the edge and now you've sort of pushed it into a problem. So it's very important to, again, think the house as a system. And we do believe that last bullet, that efficiency should not be a health hazard. So, I think the weatherization people are usually pretty tuned into this, but it's important. And this is a great example of a pollutant that we don't really think of. The pollutant was moisture, and moisture was, causing a mold and mildew issue, you can see here. And whenever there's mold and mildew, you go, okay, what's the source of the moisture? And long story short, it was an unvented space heater. So the unvented space heater was just, chunking out gallons and gallons of water vapor, and high indoor humidities. Mold likes to grow where it's cooler and darker and damp, sort of less circulation. So when this furniture was pushed up against the wall, and the wall is cold in the winter, that's what you get. Interesting. All right, so I think we kind of know what's causing it, and what are we typically finding in homes, and it's cars, it's small gas engines and things that are burning. Probably the most dangerous thing on here is not the gas ranges and gas heating, it's charcoal. Charcoal is incredibly deadly. It produces so much carbon monoxide, it just blows your mind. So to the point where after I learned this and really saw it, I'm not sure I would even run a charcoal, grill in a garage with the door open. I mean, even if it was right on the edge, I just feel like charcoal is something to be very wary of. I know some people died because it was cold and they brought a charcoal hibachi grill in their tent and they never woke up. So just be very wary of that one. And then this is true too, Joey, that when it's cold out, people close up the house. You've got your heating appliances running. Hopefully they're working. And then when does the real danger occur? When it's cold out and the power goes out. And why is that? Oh, well, probably because when the power goes out, people start doing creative things to try to keep warm. And
yeah, well, it's not just in the winter. Hurricane season's coming up, and people put their generators inside sometimes, or even in a garage, and we'll start to see stories about that, unfortunately.
That's true. And or I'm going to heat my house with my gas oven, that kind of thing. So let's talk about, if you were to simplify things, if you just had to follow 2 rules, no matter what, when you burn something, you always want to have a flue pipe that takes the combustion products to outdoors. Wow, that sounds like something the caveman figured out a long time ago. You also want to have combustion air being supplied that is really, it's not the same air as the air that the people are trying to breathe. So that's a key element there. And certain products just absolutely violate both of these. So the things that you see here, a gas space heater, a unvented, ventless gas log fireplace set, those are really dumb and really dangerous. And we should just remind ourselves that there are some stupid things that you can legally buy and put into your home. Don't do it. Right. And the code is getting a lot more strict on this because it's recognizing that we're requiring tight houses, and it basically says, you can't put this gas water heater in a closet with a louver door. you need to now seal that closet off and provide high-low vents like you see in this image. We're going to come back to that. Joey, what's a CAS? What does that mean?
Combustion appliance zone.
Mm-hmm.
It's whatever location in the house the combustion appliance happens to be. We just saw a water heater closet. Sometimes they'll be located in crawl spaces, attics, garages, where I used to work a lot in Texas was pretty common. So whatever room that happens to be is what we call the combustion appliance zone.
So I want to throw a problem at you. This is one of the things we use in our training, and it's a real story. It happened, I believe, in Georgia, and it was a few years back, but it was a family that was feeling sick, and they were actually concerned that, and I don't have I realize I'm missing the open door slide, but they were concerned the appliances weren't working, and so they had an HVAC company come out and check them. The problem is when they checked them, all the doors for the outdoors and everything was open. When the house, so the equipment was working just fine if the conditions supplied to the equipment were adequate. So the problem was with the house, and what happened was they got really sick and nearly didn't. They just about didn't make it, meaning like 2 of the 3 members of the household passed out, and the 3rd one was able to get his wife and kids out, very, very dangerous, very close to not waking up. And so what happened, we're pretty sure was a combination of building science issues, but the basic layout was they had a utility closet, very common. It had a washer, a dryer, a water heater, and the furnace in it. And obviously something caused the system to backdraft. And we were able to later show that part of it was a return leak in the CAS. So a duct right there that had partially disconnected that was sucking air right there from the CAS. Who knows? Maybe they were doing laundry and the clothes dryer was running. So the CAS was basically very negative, but it was compounded by the fact that each bedroom, when they closed the doors to the bedroom, there was a supply, but there was no return path. So the bedrooms are getting pressurized and the main part of the house is getting depressurized. And the CAS is getting super depressurized because of the duct leak. So when the system, either the water heater and or the furnace fired, it backdrafted and produced CO. And then the sad part is that CO got sucked into the ductwork, and the ductwork became the poison distribution system. And so where the homeowners end up, they lived, but one of the treatments is they'll put you in a tube and try to jam oxygen back in. So fortunately they lived. This is a fix, and again, you can fix all of these problems, and there's other ways to fix it besides just trying to fix the house issues, but they decided one way to fix it would be to put high-low vents into the CAS so that it has its own combustion air, and then obviously seal the leak in the duct and put a solid door. So now that closet is a chamber that is completely isolated from the rest of the house, and that chamber is essentially connected to the outdoors because of the high-low vents. So now everybody has their own air. They also fixed the pressure imbalance problem. So when you fix all these problems, now this becomes a much safer scenario. So again, it's all about context. There also are other fixes. We could upgrade the furnace, we could upgrade the water heater so that they're impossible to backdraft. We can choose the right equipment. We could also, to be fair, we could go all electric and not use any combustion appliances. So I just want to say there are solutions here, but it's sometimes a comedy of errors or a string of bad decisions, in essence, that nearly killed this family. So combustion closets, we looked at that. The high-low vents is an example. It's a sealed chamber. It's very important that the walls be very well sealed, that this door have a good threshold all the way around. I like to put a sign on it that says, keep this door shut, don't store anything in here. And again, we're providing combustion air. In this example from, say, a vented attic that's above it. And so there's a high and a low vent. Here's some pictures of one. I don't like this design because they did not duct the return like you see in this diagram. They actually just use the box. That's always a disaster. Today you can't can't use a cavity as a duct, but you can. The other challenge on this, to their credit, we got them to get rid of the louver door, but it's a challenge to get a good air seal on a pair of double doors. So that was a challenge, and they did provide high-low vents. So it was an imperfect solution, but it got through that house, and then we tried to change the design. This is what high-low vents look like. When I bought my house 20 years ago, the first thing I did is get rid of the louvered closet door, seal off the water heater closet, and add high-low vents. That's what they look. It's basically a 4-inch pipe with a piece of 1/2-inch mesh across the top. I wanted to mention too, terminology. Just to get it out of the way, almost all standard equipment is going to be what's called category 1. It's basically standard minimum efficiency. It vents based on warm air rising, the stack effect. And it's actually a negative pressure in the flue. So the flue, because of the stack effect, actually sort of slurps the flue gases up into it from the combustion appliance. It's pretty easy to backdraft, but that's standard, like a standard gas water heater as an example. The alternative to that is what's called category 4. And this is what you're typically going to see in a high efficiency condensing furnace. It's you're removing so much heat that there's not enough warm air to rise up anymore. So you actually have to physically blow the combustion products out. So that means the flue is now pressurized to shove things out. And it's also condensing. So you're going to have condensate to collect off of that. So that's a category 4, and that's a very safe system and very hard to backdraft. So there's really no such thing as a category 2, and there are very few appliances that would meet category 3. So almost everything is 1 or 4. With that, Joey, I want to dive in real quick to some terminology. So, and then we're going to play a game where I'm going to ask you some questions. So I hope you're paying attention, okay? So first up, if you hear the term orphaned water heater, this is where you have a scenario where it used to be common vented with a big furnace, say, and that furnace got replaced or changed out or something, and now you're not using that flue pipe, and the flue pipe that's there is now grossly oversized. In other words, too big of a flue pipe means that the water heater will not draft that well. So an orphan water heater, pretty easy to backdraft. It doesn't take much negative pressure, maybe even as low as a couple of 3 pascals. You're starting to get into the area where you could backdraft this. Certainly, 4 or 5 pascals, you're above 5, that's probably going to be backdrafted. Just saying from experience. Here's an example of one that was exactly what I described here, where they took out the old furnace and they just left it open here. And I went to inspect this, and it was about a week after they did this, and I went to look at it, and I'm like, you cannot leave that like this. It was in a building that had a preschool in it. So I'm sure the kids slept well that week. Anyway, this is what happened before it was orphaned. You had a furnace common vented with the gas water heater. And it's either of those appliances. This is an old atmospheric furnace. Either of those appliances could pretty easily be backdrafted. This is basically that furnace that I'm talking about. And you can tell it's an old atmospheric furnace because it doesn't have a little inducer fan. It has, the burners are kind of down low here. The heat of combustion goes through the heat exchanger just by warm air rising. This is called the draft diverter. I call it a scoop, and then this is the flue pipe going up and out. It's pretty easy to backdraft one of these. The good news is we stopped making these in 1992, but there are still a bunch of these out there. So were you alive in 1992, Joey? I don't even remember. I don't even know that.
Come on, Mike.
I mean, you're just a
Of course
baby.
I was.
You're just a baby. So anyway, category 1, easy to backdraft. This is also category 1, but this is what replaced that furnace. And it more or less became the only furnace you could buy or better as of 1992. So what's different about it? It got rid of the pilot light. It's got an electronic ignition. It still uses the air around it to burn with, but it does have this little inducer fan, which actually sucks the flue gases through the heat exchanger and then lets go. So it still vents with warm air rising, but because of this little inducer fan here, it's a mechanically assist fan, whatever, it does actually make it harder to backdraft this. So this is a safer water heater. And because they got rid of the pilot, and for other reasons, better heat exchanger. It's now efficiency is closer to 80%. So that's the standard furnace today. Here is that same standard furnace, common vented, whoops, I'm so sorry, with a gas water heater. And the furnace is not that likely to backdraft, but if this flue ever gets clogged up here and the furnace tries to fire, one pathway is now that this can go back into the house or come out through the water heater. So generally, I think we're seeing the industry move away from common venting. I think we're starting to see more and more just one vent per appliance, which is probably a good thing. This is the furnace that is, I'm going to say, the safe option, which is called a condensing furnace. And you'll see it has a PVC pipe that brings combustion air in from outdoors in a sealed chamber. There's a hot surface that ignites when it fires. It all burns, and all the flue gases are sucked through and then pushed out. You can't really see the little fan, it's down here. It's pushed out the flue pipe, which is this second PVC pipe. So every condensing furnace is always going to have, for sure, this PVC flue pipe right here. It has to be plastic, because if it was metal, it would corrode out and rust out in 2 weeks. And the other thing you can't see, and we'll see in some pictures, is it's going to have a condensate line, because literally we've taken out 95% of the theoretical heat. So what's being pushed out is just warm water vapor and combustion products. And so that water vapor will condense, and so we'll collect it and drain it off. Any comments on that, Joey? Any thoughts on that?
Yeah, I don't want to spoil it, but make sure to be wary of one pipe installations. That we might talk about that in a little bit.
Yeah, it depends on where it's located, but yes, that is correct. And generally, we're looking to see 2 pipes. This is a concentric vent, which means there's actually one pipe inside of a bigger pipe. So the 2 air streams are not mixed. It's not a T in that sense. Yeah, let's drive on. And in terms of water heaters, this is the standard water heater over here. It's a gas tank water heater. The burner's down at the bottom, the flue and the draft diverter up here at the top. That's of course, the temperature and pressure relief valve, vented out, ducted to outside here. Pretty easy to backdraft this, pretty low technology. It doesn't take any electricity because it has a pilot light burning, and that keeps its efficiency lower. The safe upgrade from this is literally the exact same water heater with some different venting on it. And this is where you have essentially a pipe inside of a pipe. And it's called a direct vent water heater. So the combustion air comes in through the outer, if you will, donut part of that. It goes down, it burns, and then the flue gases come out through a middle pipe that exhausts out. That's it's virtually the same water heater, so same efficiency and so on, but pretty much I'd say pretty much impossible to backdraft this one. Very easy to backdraft this one. It's the same water heater, just with different venting. I don't understand why, but they charge almost twice the price for this one on the right, which is crazy. Upgrades would be some sort of mechanically assisted drafting or venting, and you can see what's happening in this one. This is power vent. This is a tankless with a power vent, and this is more like the 90% 2-pipe furnace right there. Okay, Joey, we're going to play our game here. I'm going to show you a picture, and you have to describe what you see, and then you have to tell me, does it feel like it's safe or not? Okay, and then the 2 rules right here. Go ahead.
And I might need a little bit of help. So if everyone's still paying attention, go ahead and shoot me some hints here in the questions, and maybe we can get it together.
Okay. All right. So for this one right here, we're looking at pretty standard gas water heater in a garage. It's elevated. I'd say that one looks pretty good. All right. You ready, Joey?
All right, I'm ready.
Okay. Here we go.
All right, so this looks like one of those old ones you were saying. They're older than me, a ream. So natural draft furnace here. So there's definitely some safety issues here. One would be the louver door, so it seems like it's pulling air from the occupants, and very, very easy to backdraft. So if the air can go up through those louvered vents, they can also come out through those louvered vents as well. So not a very safe situation at all.
Beautiful, well done. Yep, and here's the scoop I was talking about, and here's the flue pipe, and these are the burners down here. Okay, let's see. Let's try to throw you a curve. What's this?
Okay, no combustibles, so that
Hmm.
that seems safe.
Right.
So I think it's the same one. You just created a different kind of scoop element to this one, I think, and it looks like
Yep.
it's horizontally installed. So maybe this is in an attic or a crawl space or something.
Yep, that's exactly right.
But
This is the same furnace, only it's running horizontally. So the burners are down here. Here's the scoop. You know, yeah, you're absolutely correct. And
hmm.
no combustibles. So that means don't store anything that can burn right in front of those burners. That's good advice. I like that. All right, what are we looking here on the left? What is this one? Letter A.
Okay, on the left, it looks like one of those two pipe furnaces, but I'm only seeing one pipe for some reason.
Hmm.
But it seems like it might be the sealed combustion type. Um, there's this weird thing on the left side here. Looks like some sort of install on the side of it. Maybe that's a humidifier, so this is maybe a
That's
colder
right.
climate.
Yep, yep, very
But
good.
I don't know why there's only one pipe.
Yeah, it looks like it's in the basement, doesn't it? And
Yeah.
yeah, and again, every time it pulls a cubic foot of air for combustion and then throws it out here, it's basically driving more air has to be pulled in now into the basement. So contrast that one, Joey, with picture B.
Yeah, so this looks a little bit better. I definitely have two pipes. It looks like maybe they just recently replaced this one because I'm seeing a brick chimney on the side here with looks like a
Oh, wow.
plug.
Yeah, yeah.
So,
Good eye, man.
and and drawing on some of our other webinars, I'm seeing a nice taped air filter area down there too.
Uh-huh.
So this
Right, yeah.
looks like someone knew what they were doing here.
Yeah, so it's the main thing is it's one pipe in for combustion air and the other pipe pushing it out. So very safe, and it's not taking any air from the space around it. So
Mhm.
uh, very efficient as well. What do you think about this one?
Okay, you turned it on its side again.
Very good.
So definitely looks like it's on a crawl space. I think actually I've even seen this picture before.
Uh-huh.
If people are paying attention, this is it's like a horizontal unit, two pipes again. Just from what I can tell, it looks like this might be a closed crawl space, a conditioned crawl space.
Yep.
So if this were just a one pipe scenario, it wouldn't be able to get any oxygen from anywhere, except
Right.
maybe through the subfloor and
Yep.
stealing it from the occupants. So not good. But it
Yeah,
looks
we're
like
going
they
to
got
talk about that. No, very good point that ultimately, though, if this is a condensing furnace and it is in a closed crawl space, it has to have two pipes. If it
yeah.
is a vented crawl space, theoretically, you can get by with one, but it's always
Mm,
better to
yeah.
use, I think, the two pipe. And this is kind of good segue into this. What are you looking at
Yeah.
here?
So it looks like almost the same thing, except I'm only seeing one pipe. And the attic, I mean, the attic doesn't look particularly well sealed. I don't see any spray foam or anything, but still, I don't love the idea that it's still pulling the air for combustion from the attic because it's going to be laden with fiberglass and all sorts of other nasty stuff that you probably don't want to get
I would
in your front.
say I don't have any disagreement with you. I would say though that uh, this is okay. It's
Yeah.
acceptable because you are outside the conditioned space and you are
Hmm.
pulling combustion air from a vented attic. So in that sense, it's really no different. But if you were to foam the roof line and
Hmm.
retrofit this, you would absolutely need to run the second PVC pipe. Very good. Let's keep going. All right. Now this was my friend's house. So we saw this
Okay.
furnace and
Hmm.
they asked me, they took a picture and said, do you think we should get a new furnace? And I said, oh yes. And we're going to bypass the 80%. We're going to go to a 95%. And we're going to put in a really good filter. And that was all I told them. And this is what was installed. So tell me what you see and what should I have also added?
Okay, so it looks like a 90 percenter. I see one pipe. I don't see
Yep,
two pipes, so that's
yep,
unfortunate. I'm seeing some
yep,
other nice gizmos though. It looks like an air cleaner, and it looks like the
yep,
return was even ducted. So
yep.
um, certainly
Yeah,
efficient. And
no, you nailed it, and I, it was my bad for not being explicit enough, but the lazy HVAC installer, yep, I went there, just said, oh, we'll just keep getting the air from the house. But again,
yeah,
if you do this, every cubic foot of air that's pulled from the house means one has to infiltrate back in. So, you know, I made them go back and add a second pipe. Okay, what are we looking at in this picture, Joey?
Wait a minute.
I don't see any
That doesn't
ductwork.
that doesn't look like a furnace. What are all these copper pipes? So this
I don't
I
know.
think is a boiler
Yes.
from my time up in Chicago.
Uh-huh.
And it looks like I don't see any metal pipes, so I'm guessing this is some sort of high efficiency unit too, with those
Yep.
PVC pipes on the back being the flue and the intake as well. So
Well done. In the interest of time, I'm going to jump in and just say these are both the same. They're both standard 80% efficient furnaces. So they're getting their combustion air from the space around them. So they are having that issue with every cubic foot of air going up the flue means you're driving infiltration. It's probably hard to backdraft these, but it's a possibility. And then this one, what are your thoughts on this picture?
so commonly vented, so not ideal. But it does look, it's the same mechanically assisted furnace. So if they were to replace this furnace with a 90%, you might have an Orphan water heater. So that would be unfortunate. I certainly have thoughts about their plumbing as well, but we won't get into
Yeah.
that.
Yeah, and this was actually a friend that had a townhome, and this was in the very bowels of the center of the building on the main floor, and there
Yeah.
was no easy way to get combustion air to this. And
Hmm.
you know, of course, now they're getting it from a louver door. So I said, you know, probably the easiest thing to do here would be to replace the furnace with a condensing furnace, two pipe, and that can be, those can be run in you know, in wherever it's easiest. And then the water heater, probably upgrade the water heater to either upgrade it to a direct vent or try to use, now you've got space up here, you know, maybe you can provide high-low openings essentially in what used to be the flue chase. And no easy answer on that one for sure. And you know, this is where whoever built this home followed the code. Yeah, sure. Houses are leaky, sure.
Right.
But they really, you know, left a hard challenge for the homeowners. And then this cracked me up. He found this, which said how to convert your
Yeah.
water heater closet to a wine cellar. That's
Yeah, basically. So this is in the code. Do not use your water heater area for storage. You know,
okay.
we've got some issues with combustion. You don't want it, this one here on
That's
the
all right.
left is like baby food and stuff. So you don't want baby food. I mean, it looks like an electric water heater, but I still don't want it getting hot and getting cold. So
Yeah.
don't trust what you see on Pinterest. You know, follow the code.
Well, it does say fuel fired, so that's good. These, of course, on the left is, I'm going to speed us up, unvented space heater. On the right is you know, maybe a gas log or something. It does have a flue pipe, and it's hard to tell. It may have combustion air. So option A, or the left side, that's a big no-no. What do you see here, Joey? Probably the pre and post. It looks like
Yeah.
they have an 80% furnace and a standard tank water heater that they upgraded with, you'll notice by the PVC, a two-pipe condensing tankless gas water heater. So at least the water heater now has its own combustion air being taken care of. What do you think of the one on the left?
That looks to be on the outside of a home.
Yeah, yeah. And, you know, it's probably more of a Gulf Coast type application because I would certainly say insulate the water pipes so they don't freeze, but, you know, it is a safe installation. You can say that much for it. Whereas the one on the right is more or less the same water heater with a flue, but where's the combustion air come from? I see a high louver and a low louver. It's coming from the house. So not ideal. All right, Joey, I know what the one on the left is. It's a gas water heater tank standard. What's the one on the right?
It just looks like a regular electric water heater. No flue pipe or anything there.
You're so smart. Yeah, there's no flue on there. And the strapping, what did we figure the strapping is for?
This is probably on the West Coast for earthquake seismic reasons.
Oh, okay, I thought it was maybe runaway water heaters, but
Yeah, put a leash on them.
some nice details about when you should use a pan. I would say you should pretty much always use a pan and make sure that pan drains to somewhere. Not just put a pan, and I've seen people put a pan and that's it. So it actually goes somewhere.
Yeah.
And then I also think we've touched on this, that we want to elevate gas water heaters in a garage because of combustion safety concerns with gasoline spills. Gasoline spills, the vapors can travel horizontally and ignite if the water heater burner is sitting right on the ground. But if you elevate it 18 inches, it's very safe. So most people, I think, are tuned into that. This is just more detail about the temperature and pressure relief valve and how to run it properly. I'm going to speed us along because I want to make sure. Oh, well, I do have to talk about this one. Just so you know, this is a commercial kitchen, and this is really a standard atmospheric gas water heater. It's got a few bells and whistles. It's got a motorized damper that's just normally closed at the top of the flue. That just prevents standby losses. And it doesn't have a pilot, so down at the bottom, it has an electronic ignition. But when it fires, the motorized damper opens, the sparker ignites, the burners fire, and it drafts based on warm air rising. So Joey, do you see any possible scenario where that could be backdrafted?
Oh, spending a little time in commercial kitchens, and I know how much CFM is going up that vent there. So yeah.
And it's right next to it too. So I would say it's probably backdrafted. All right, this is what I want to make sure we cover. And I'm going to give you a little commentary here. The fuel gas code, I'm going to say, was written with a 1950s mindset that houses are leaky. And it allows you to do some really stupid things, like get your combustion air from the house. That's a big no-no. But it also has some really good things in it, such as get your combustion air from outdoors. And that would be, they call it the two permanent opening methods. I always call it the high-low approach, where you put, one within the ceiling, one within the floor, and they're sized based on how many BTUs each appliance is. And we'll talk about that in a little bit. I also want to make a pitch, and I'm going to come back to this at the end. Use those toolkits, because there's a really good little 50-page book that's got a lot of pictures in it, but there's also a spreadsheet that kind of walks you through and helps you with the math. And it asks you questions as you go. So again, lots of good pictures like you see kind of showing horizontal. Horizontal, you need 1 square inch for every 2,000 BTUs. Vertical, you need 1 square inch for every 4,000 BTUs. So you need basically a bigger duct if you're going horizontally. And the other big thing is, I think everybody on this webinar can walk out of here knowing how to do this calculation. And the calculation is to determine if it's getting its combustion air from the house, is it at least compliant with the code? And by that we mean, is it considered unconfined, or is it a confined, meaning it's too small of a space? And either way, it's dumb to get combustion air from people air, but at least we can do this quick test. And the rule is you need 50 cubic feet of volume that the space the appliance is in for every 1,000 BTUs of the appliance. A better way to do it is you just divide the BTUs by 20. And the best way to show that is with an example. So here is a CAS that has 3 appliances in it. 75,000 BTU an hour furnace, a 40,000 BTU an hour water heater, and a 25,000 gas dryer. So it's also got a pretty decent sized room. I mean, 14 by 10, 8-foot ceiling. So we're going to do the calculation of the CAS volume, and it turns out it's 1,120 cubic feet. And then we're going to say, okay, how much volume do we need because of these 3 appliances? And you add them all up and you divide by 20, and the answer is, oh wow, we need 7,000 cubic feet. So we need a factor of 5 basically of what we actually have. So that's another thing, is that you never have as much volume as you think you have, and I'll try to reinforce that later. And if we wanted to fix this and make it code compliant, we would just simply need to run 1 square inch for every 4,000 BTUs per hour if they're vertical pipes. So we're going to take the total BTUs, divide it by 4,000, and it says we need 35 square inches. So you do the math, you put a couple 7-inch diameter pipes, or 8-inch if you want to go bigger, and each pipe is big enough. And so you have 1 from the ceiling, 1 from the floor. Now this chamber can be completely air sealed from the house. It has its own combustion air. It's a lot safer. And again, use the tools just to help you with the math. It'll add them all up for you. It'll tell you, what the size you need is. You can answer questions like, I'm getting it from the building, okay, or from the outdoors. What am I doing? What size duct, et cetera, et cetera. Okay. I'm going to throw one more problem at you, and then we'll probably take some questions. This was my parents' house. It was a brick ranch house with a utility closet on the carport side of it. There's the water heater. And it had a lot, it was big. It had, tall ceiling, had a lot of space in it, had one gas water heater. So if I had you calculate the volume of it, you end up being 855 cubic feet. And then you do the check, is that enough volume? And the answer is no, it needs more than twice the volume for just to handle one gas water heater. So it's definitely a confined space. How do you make it safe? Well, there's a vented attic above it. So all we got to do is drop a pipe from the top, and we're going to do a high and a low, and each one, we only need 10 square inches. We'll put a 4-inch pipe. That's 12.5 square inches. So there we go. Joey, any comments or thoughts on that?
I don't know. I don't like having our tool bench right by our water heater.
Yeah, I
might recommend a heat pump water heater or something.
Pay no attention to my dad storing foam board right behind the combustion appliance there. So yeah. Last thing, we've said this before, but if you have a foamed roof line, or if you have a unvented conditioned crawl space, you may not use this type of appliance in it. And you can't say, well, I'm going to put high-low vents to now, because then you're violating one code or the other. One code says you're getting away with this being an unvented attic space, but if you cut holes in it, now you're venting it. So you cannot use this type of combustion appliance in a foamed roof line, for example. You must use a 2-pipe high efficiency system or a heat pump. Okay, and with that, I think the rest of the slides in here all are stuff I knew we weren't going to get to. I just wanted to put it in. If you're interested, you can read about things you can visually inspect for soot and corrosion and proper slope of the flue pipe. Flue pipes always have to go up by at least 1/4 of an inch per foot. Condensation occurs if they aren't, and all kinds of problems. And some of these I took, some of these I found on the internet, and disconnected flue. So there's a lot of stuff you can do. Someone getting creative with the word vent. Don't ever put a flue made out of plastic wrapped duct. And just some good things, inspections and older furnaces. You used to talk about cracks in the heat exchanger. Here's some pictures, and making sure the CAS is cleaned up. So there's also, if you want to go deeper, there's a webinar about this booklet, but I'm going to challenge the people on this webinar to get a hold of this booklet. And it's written for somebody like me with a short attention span, so it's got a lot of pictures, but I want you to read it and really learn about case studies and context, because it's all about context. All right, Joey, there's one more thing I want you to talk about, which is this thing right here.
That looks like my apartment right there.
Why is this a bad thing right here? Why am I going to put an X over this?
Yeah, it's interesting that we do so much testing on our furnace and our water heater, and we want to make sure it's vented out and that it's functioning properly. And then when it comes to our oven, it's not vented at all, or the stove that's vented with this, or in this case, not vented at all. So what's happening to all that carbon monoxide? What's happening to all that moisture? It's just flowing right back into your face. So a lot of new research for indoor air quality is really going toward that. Not only is the flue vented to the outside, but it's large enough to cover the stove, and it comes out and captures all that effluents.
Yep, I would say you should never ever operate a gas oven or a gas cooktop if it does not have a hood, and you should never. And the hood, of course, ducts to the outside. This is terrible. A recirculating hood is awful. So you want to make sure that whatever you're burning, and the other, like you mentioned, the back burners, the conventional hoods today draw a lot better on the back burner. So always use the back burners as opposed to the front burners, unless you need 3. So very important to mention. And with that, I think we made it to the finish line. So
I actually did do I did do a poll for this one, and I'm not sure if you're presenting. Can you see that? I'm guessing not, so I'll have to read it to you. So
Okay, sorry about that.
basically, no, it's okay. It's our weekly call to action, or in this case, monthly. What are you
Okay.
going to do about combustion safety in your home? So are you going to install a CO monitor with a digital readout? Are you going to configure your return and supply air pathways to reduce pressure? Are you going
Hmm.
to get rid of gas appliances and go all electric? Are you going to make sure that are you going to make sure that your vent hood goes to the outside? Are you going to remove storage items from your combustion closet? And unfortunately, I think I set the settings here that you can only choose one here.
Ah.
Um, so you got to pick the best one.
Are
All
people
right, so
able
we're
to
gonna
see the poll? Are people able to see the poll?
yeah,
On.
it looks like we
Oh,
got
okay,
about
good.
half the people have chimed in here. So let's
Good deal.
shut
Good
this
deal.
thing down. I'm gonna share the results here. It looks like a lot of people, as always, it's interesting. Really like those CO monitors with the digital readout. So again,
Definitely.
I
Definitely.
think you said $100. I think that's about right. It's worth it, and we don't get any kickbacks. We're not sponsored by Defender or anything like that. We
Yeah,
just a good product. And
we're nonprofit. We only lie for fun, not for profit. So that's our mantra. But no, I definitely
um,
want to advocate for those. They usually have a sensor and a battery that are designed to essentially when one wears out, the other one wears out. So you just buy a new unit. But if it's $100 and you get 7 or 8 years out of it, that's not bad. I'm pretty sure I got at least that out of. I had the Defender and
mhm.
I was pretty happy with it. So. Um, any other comments from the poll or thoughts on that?
Yeah, we
Um,
got a question or two. I just,
okay.
as always, if this is your first one, what we generally do is try to wrap it up by 12, which somehow miraculously we did it today.
I don't
Great
know how
job,
that
Mike.
happened, but yeah, you too.
And yeah, we'll be around for another 10 or 15 minutes here to answer questions. So if you have any questions, go ahead and get in that Q&A. And if you need to leave at noon, thank you for joining us. And we'll be back on, looks like July 16th to talk about HVAC load calculations. So
Looking
I'm
forward to
excited
that one.
about that one for
Yeah, me
sure.
too. Me too. And
And
I do
and
want to make a pitch too. Can I make a shameless plug that I'm going to be broadcasting another webinar today at 3 o'clock Eastern time for EVA. So this one is about energy modeling and and a little bit about load calcs and UA analysis. So if that's of interest to you, jump on those. We're doing a series of 5 hour-and-a-half webinars for EVA, and those have been a lot of fun. But in terms of combustion, there's so many great stories to tell
yeah,
that this is one where I feel like we could stay on for hours just chatting about things we've seen, and a lot of that got captured in that small commercial workbook. So if you've ever been on a webinar where someone at the end goes, "Oh, I want you to buy my book," and that's basically what I'm saying is buy my book, but it's free. So can I say that? At least it's free. And it really kind of again addresses this context issue there. That's the book up there. Yeah. So with that said, Joey, what do you have? Any questions or comments?
yeah, sure. We got a couple of questions, so we'll go through them here. So combustion closets, how did they get into the code? Safety, was it energy savings? Did they back up their savings calculations with any sort of data or anything? And I think I have an idea that this one might also be one of those political things, but if you could talk about combustion closets or,
Yeah, I mean, I can
uh,
try to address that. I'm trying to remember where that slide was that we had one showing. I think it was somewhere there. That was a pretty good one right there.
oh
So
yeah, and
I
this,
did.
just a quick plug too, speaking of selling books, this is in our field guide for the energy code. So it's a really great diagram on how to do this one properly. So
Yeah, yeah,
again,
yeah, yeah.
pick that one up for the
And
low
that's
cost of $0.
also free, right, right, right. Um, but will you autograph it, Joey? That's the real thing. So I'm going to tell you my story on this is I started building habitat houses back in the early 90s, and the local affiliate that I was working with at one point had been doing louvered closet doors and gas water heaters, and they, obviously very easy to backdraft. And I can't remember if it was us or Southface, or maybe they had kind of started doing it this way, but we got them at some point to do a combustion closet, which was a huge improvement, in my opinion, in terms of safety and a little bit of an efficiency gain. They were pretty easy with the idea of, we said, you're going to need to insulate the 3 walls of it, and you're going to need to put a door that is, it doesn't have to be an exterior door, but it needs to be, you know, a solid door, no louvers in it. And they were okay with that. And then the HighLow vents, they said, yeah, we can handle that. And then we started blower door testing, and we realized that they were doing a horrible job of sealing the closet from the house. So while it was an improvement, it was by no means perfect. And you know, I kept saying, you can take a 2x4 and put it up, screw it into the floor so the bottom of the door closes against it, and just put weather stripping around it. But to be fair, with volunteer labor, you know, trying to get the tolerances right and the gap to be consistent, it's a little bit of work to make that really be airtight. And I'll say that from experience. I've done it, but it is a bit of a challenge. And then they never seem to get the details like air sealing the wall penetrations really well. Some people think they had to seal the ceiling of it. I'm like, no, the ceiling is vented to the attic, so you don't have to worry about that. But the walls being airtight was a bit of a challenge. And at some point, I think one of my, many years later, you know, one of my colleagues gave up on him, and she got him to go to all electric, which I don't necessarily agree with, because the cost to the homeowner is significantly more. If all electric resistance water heater, which is what they're putting in, is, you know, it's going to cost the homeowner $600 a year versus gas is, you know, $100 a year, so 120 or something. So it's there's an economic disadvantage that, but I think you could make an argument today that if you put in a heat pump water heater, and obviously we need as a nation to be thinking about, we got to green our electric supply, and then we need to stop burning fossil fuels. Right now, I'm not sure, at least in Georgia, that we're at a point where you could say electricity, all electric homes are necessarily better. You are kind of future proofing, but because you're just shifting the, you know, emissions from your house to the power plant. We're burning a fossil fuel to make electricity, coal or natural gas. So as we retire coal, that gets better along that front as well. But from a CO2 standpoint, but I don't know when this got into the code. I will say that it is a fair amount of work to do this correctly. And it's one thing to do it correctly for a gas water heater. It's nearly impossible to do it correctly for a furnace, because furnaces have ducts coming into them and out of them. They have, you know, more refrigerant lines, just more penetrations. And so I would say, don't do it. You can put your money into building the closet, or you can put your money into making the water heater a safe water heater. So really, a direct vent gas water heater is basically saying, I'm going to build a closet around the water heater, but the manufacturer is going to do it for me. I don't know if that answered the question, but I would say if you have this and the details are done right, the walls are insulated, the closet is truly air sealed, including the door, and you provide high-low vents, I think it's an acceptable way to have a gas appliance. It seems like, and Joey, you mentioned this earlier, it seems like a lot of new construction builders have just moved it out to the garage, which is also an option. Move it, and I think in warmer climates, then maybe put it up in the attic even. It's got its own set of challenges.
And for retrofits here, one thing we haven't really talked about is insulating those walls, which is nigh impossible. Hopefully on, you know, on new construction it's done, but I think I have my doubts about that as well, unfortunately. So it's an imperfect solution for sure. And speaking of which, someone was asking about putting those water heater closets either outdoors in a closet. Do we still need to do any testing? Are you concerned about CO and everything there?
Well, you know, that's interesting. I would argue that if your water heater closet is, let's say it has an exterior access door, and it's truly air sealed from the house, and the access door probably has louvers, or else it's got high-low, or it's got horizontal louvers or something. If you could sort of do a zone pressure test with a blower door, that might be another way to prove it. I'd say that's more of a envelope commissioning setup, and that's probably safe. I would say I like that better than having it be inside the house like you see here.
Sure.
So I think that's okay. I was going to say something else. Oh, you know, the code basically says you can get combustion air from outdoors, like with high-low vents, or the code says you can do something stupid and get combustion air from, say, louvers in the door. The code also has something stupid. It says you can do both at the same time. And guess what happened? We saw that in some fire stations where they had essentially outside air to the CAS, and they also had louvers from the CAS into the main living space. And guess what happens? It gets cold in the winter, and people go, hey, it's really cold, and a cold air is coming from that closet. And so you know what they do? They close off the high-low vents. That's exactly what happened. They didn't close off the louvers in the door because, you know, so I thought that was kind of sad but funny, but also true. So don't get combustion air from both places. Don't get combustion air from the building, period. Just don't do it. And if you can imagine if you move that water heater just straight up into the attic, all of a sudden, you know, that's what they do in Houston. And now that's in the vented attic, and it's got its own, you know, combustion closet up there.
And it's highly efficient because it's very hot up there, so you barely need any gas.
That's right.
If you could go back to the slide about the CO, the defenders, I think there was some issues, and it's probably my fault about just the semantics of it. And I don't know. When I put this slide in here, even the defender, would you consider that a monitor, a detector?
Yes.
How do we?
So here's how I understand it, and I think this is correct. The word CO detector and CO alarm, those are kind of interchangeable.
Okay.
And that's what the UL standard refers to, and that's the one that they intentionally said, yeah, you can't make this thing too good, or else you'll get quote nuisance alarms. You know, nuisance alarms. Oh yeah, you're only getting exposed to 20 parts per million. But
that's not too bad.
So yeah, right. So the what you want, in my opinion, is what is intentionally called a CO monitor, and it is intentionally not going to meet UL 2034. They wrote a standard to basically punish CO monitors. So you want a CO monitor because it will detect at much lower levels, and it will give you usually a digital display. So yeah, very good.
All right, I think that's it for the questions. So if you could go back to the last slide, I want to make a point of clarification here if anyone's still around for her CEUs. We're in the process of applying for the CEUs. No guarantees on this one. They're not, you know, that has to be as a certain standard. So we want to make sure before we advertise that, I mean, we filled you up with so many CEUs. I can't imagine you need any more, but it's the case.
It surprises me that ResNet would try to give you a hard time about this, because I think this is so important. And I want to wrap with that, what I think is an important message to people. And there's still a good chunk of folks that are sticking around, so thank you. I want to talk about testing. And you alluded to this earlier, that I have no problem with testing. You know, we train people in BPI, we train people in ResNet to do combustion safety testing. And I'm not saying there's no value to it, but it's also, let me try to use an analogy that might work for you. Let's say I go get a coronavirus test. I drive up and they take a swab, and then you know, I'm doing this because this weekend I want to go out and party and hang out, and I'm not recommending you do that, and go to a bar and go crazy, and then find out later that the test was good, but the test was a snapshot of me at that point in time, and so now I got to do another test, I'm probably going to say the issue I have is that it's just a snapshot on that day under those conditions. And yes, we try to do our combustion safety testing under worst case, but the reality is that you know, things can change. And so I really think it's better if you can identify a situation, if you can go back and say, does this violate those two rules for safe combustion? And if if it passes the 2 rules for safe combustion, it's probably gonna not have a screw up that causes something dangerous to happen. And that does not involve, measuring carbon dioxide. I totally get it or measuring, CAS pressures and things like that. There are all kinds of great tests you can do. The commercial combustion, the small commercial combustion field guide talks about all the different tests that you can do and walks you through a protocol for them or helps you make your own protocol. But ultimately, just appreciate the limitations of safety testing. And one more rant, and at least at one point in time, a program that I have a lot of admiration for, Energy Star, was allowing you to still have, essentially a gas fireplace that, they were like, yeah, you just have to do a test on it. Here we are building a super tight, efficient home, and you could do a dumb combustion thing. And all you had to do was do a test on it. And as long as you were below 35 parts per million, you pass and you can be Energy Star. And I'm like, no. And so that's why Earthcraft, we take a much harder stance on that. You just can't have that appliance, period. It's a deal breaker. So
yeah, and kind of following up with that, it's a point in time. My family, my parents have a unvented gas logs, and I tell them every time I'm there, you got to get rid of this. And my dad says, well, you tested it and it was fine. I was like, yeah, Dad, that was like 10 years ago.
yeah.
So
What else
yeah,
changed
keep
on
that in
the
mind.
envelope?
And remember to use the best tool you have, which goes against going to party this weekend out, is use your brain.
Yeah.
So keep that in mind. Don't get tunnel vision. Tests are good. We're fine. And forget about these kind of these crucial elements of building science and house as a system that we've talked about.
Well, there's our email. So please feel free to say, you guys were really stepping on your soapbox this week. So, love your feedback on all this, but this is one that I do feel very strongly about. And again, really appreciate the people on this webinar and the good that you do. And, go out and use that great power with great responsibility.
There you go. All right. Thanks, everyone.
Thanks, Joey.